And yes, my name is Soni Jiandani. I'm the Senior Vice President of Marketing for NCMA Business Unit. Obviously, that is not true. Soni will be here in a moment, and I'll just get it started while we're waiting on her to show up. She's just a minute late. If you don't know who Soni is, the reason I wanted to bring her in is I know you come to Cisco a lot for these events, and most of the time we bring in a product manager, a technical marketing engineer, an idiot like me, that type of thing. We wanted to bring in somebody who has a lot of history in the networking industry. Everyone here, I'm assuming, has worked with the Catalyst product line. Soni and team brought the Catalyst product line to market. It's Cisco's first switching product. Soni and team then spun out a company called Andiamo Systems. And Andiamo Systems built the Cisco MDS product line. And that's Cisco's storage networking product. That's about 50% market share today in storage networking. After that, they spun out a company called Nuova Systems. And Nuova Systems built Nexus 5000, Nexus 2000, and the Cisco UCS platform. UCS today, Cisco's first server, #1 blade server in North America, #2 worldwide. This is the same team, Soni being the marketing lead for that. Mario Prim, Luca, and Soni are the full executive team that have done this, affectionately known as MPLS, which is perfect in this industry, right? So we're going to talk again a little bit about ACI, and I know we've done that in the past a bit. I'm just going to go through, this is your little marketecture pitch. I am not going to be presenting all day today or presenting again today. I know you are tired of hearing me talk, so I brought in Carly Stoughton, who is one of our top TMEs on the team, and she's going to spend all day on the whiteboards and skip the slides for you, because I'm sure you'll see plenty more slides the rest of the day. But kicking into just a little bit of what ACI does and where we're at, the marketecture stuff. If you look at where the industry's going and what we're doing, we've got several shifts that have happened. We went through this idea of unified fabric with LAN and SAN. We took fiber channel and we started to put it over Ethernet. We started to unify how we deliver storage, and it was a very successful technology, especially at the access layer. If you're using UCS, most likely you're using fiber channel over Ethernet, and you most likely don't know it's there. Then we started to move into taking compute and taking storage and the networking and blending those pieces together. These are the Cisco transitions that we've been trying to take our customers through. Now we're moving into the application-centric infrastructure and ACI. This is the next evolution of where we're going. What we want to do is look at the network as a delivery system for applications and services, because that's what it's there to do. As networking professionals, we're there to support the apps and services that our customers or our businesses run. Fair enough? So we're trying to tie what the application is, what the business policy for that application is, into the network, and do that in an automated fashion. How many of you have been involved with bringing a new application online on the infrastructure? One that was maybe developed or just architected, a pre-built, pre-canned application even? Most everybody? Would you say I would say, would you agree, the biggest challenge when you start to do that is the human interaction between the people that understand application architecture and what we have to do to support it on infrastructure? Turning tiers of application security, compliance, governance, and risk into VLANs, ports, protocols, and firewall rules. Is that one of the more difficult parts of what we do? And we typically do this in a throw it over the fence fashion, right? They develop, now it's ready, here, go make it work. When they developed it, they probably didn't develop it with firewalls and load balancers in place, because that's not how we develop code. Then they throw it over at you, and you've got to insert these layer 4 through 7 devices, and now you end up finding things that are broken that have nothing to do with the code. They have to do with the way the code is being implemented on a different set of infrastructure. Does this make sense? So we're trying to tie that policy down, and we're trying to do it in an automated fashion. We're not trying to do something that eliminates a network engineer. We're not trying to do something that eliminates a developer. We don't think that network engineers have to go learn how to build software, but it would be good to have some development skills, but most of us already have some scripting knowledge and things like that. So when we look at ACI, the thing that we're really trying to do is an automatic translation of what the app requires down into how the infrastructure provisions it, and then visibility that's relevant back up to whoever is getting that visibility. If I'm an application owner looking at ACI and I go into the ACI GUI or the ACI interface, CLI, whatever it is, I see my application tiers. I see that this is my Exchange server, it's attached to this other group of servers. I see what my application looks like from an architecture perspective. I know how they connect, and it's the same way I would whiteboard it if I was the app architect. If I'm the network engineer and now I have to troubleshoot Exchange, I don't now have to go to a spreadsheet to go and translate what VLAN or subnet is this sitting in, to go down and figure out where I need to start looking for connectivity problems. So I get information that shows me this is the application I'm actually troubleshooting. This is where the problem is. And then I can drill down into latency, packet loss, drop, throughput, all the things that we have to deal with to troubleshoot, mitigate, and get things back up. Does that make sense? Okay. The other piece that we focus on quite a bit with application-centric infrastructure is not just getting apps deployed more quickly, because agility is one of the things that everyone is talking about in the industry right now from an infrastructure perspective. Any conversation you have, somebody's going to talk about app agility or this, that, blah, blah, blah. Getting an application online fast is great. But once an application's online, now you have users, and now you have SLAs, and now you have expectations. We have to be able to keep these applications online. So one of the things we've focused on quite a bit is that ability to troubleshoot down into where the application is having a problem. One of the things I think we do best with ACI over a lot of the solutions out there, and this is my personal opinion as a guy who's paid to sell ACI, so take it with a grain of salt, is troubleshooting an app. If a user can't send an email, they don't call and say a server's down. They call and say email's broken. And when that troubleshooting team, whatever they may be, gets that call, who's the first team they call?
It's the network's fault.
It's the network's fault, right? It's always the network's fault. And then the network team usually says it's a security team's fault, it's firewall. But network's job, and most of our jobs when we're working on a network on a day-to-day basis, is mean time to innocence. How long does it take me to prove to you that I'm not the problem? Does that make sense? So one of the things ACI really focuses on is that ability to show, hey, the network is up and healthy now. The application itself, from the virtual to physical components that drive the packets, is healthy. And then when it's not healthy, to drill down and show you where it's broken. It's this tier of the app not talking to this tier of the app, but the packets are being lost, or the throughput's bad, or whatever it may be. Now, when you look at a network today, you're all very smart networking engineers. That's why you're here. If I said it's very easy to tell that an FTP server is dropping packets on a network, would you agree with that statement? I have an FTP server to find out that that particular FTP server, I know which one I'm looking at, that it's dropping packets. Is that pretty easy?
It's easy, but it's tedious.
Yeah.
Easy but tedious, just for a single server, just to know that it's dropping packets.
Right, yeah, you're right. It's easy but tedious.
You can look at the port and see that you've got
Right.
errors, like just a single port, right? Now, if you have a real data center network, multiple switches, access switches, but however, 3-tier design, 2-tier design, doesn't matter, to find out where those packets are dropping, how easy is that today?
It's just a matter of running down the path, right?
Yeah, running down the path, multiple switches, multiple command lines, finding it all. With ACI, we look at the network as a system for the delivery of applications and services. So when packets are dropping, when you're having loss, when something like that is going on, we don't tell you you have packet loss and latency occurring. We tell you which link it's happening on, what the latency of that path is in real time, and where the packets are dropping. It's part of the telemetry and troubleshooting pieces that we built into the system. So, yes, sir.
You had me earlier with sort of the you didn't quite say it, but one of the problems I'm seeing a lot is services applications are undocumented. So it takes a while to find out what are the IP addresses of the servers delivering that application. And ACI implicitly does that for you. So.
Absolutely. In a lot of places, how many of us build and work with our networks based on spreadsheets that are showing me what I've subnetted, what VLAN's here, what's there? When you have to go troubleshoot an application, you're going back to these spreadsheets. And sometimes we move those spreadsheets up into software that do it a little more intelligently, so on and so forth. But it's still a difficult thing to go and take that application and figure out what the infrastructure looks at it as to transition. So ACI is tying that network application and policy down into the network and looking at it as a system for delivering applications to help run the businesses. And it's a step in getting up to enabling the cloud. It's a step to getting our customers to be able to deliver IT as a service or whatever other buzzword you want to use. It's a step in being able to build private clouds and, more importantly, hybrid clouds, which is where the majority of the market is moving today. Now, with that being said, I'm going to turn this over to a much better speaker with a much better title. My boss's boss, Soni Jiandani, Senior Vice President of NCME Business Unit, and I think you're in really good hands.
Thank you. Thank you very much. We do need a mic, huh?
Yes.
Okay, no problem. I will use the mic. I guess it's for the folks that are remote. Okay. All right. So as we were just walking you through this, none of these innovations are in point in time. One builds on the other. So if you take a look at the unified fabric, it was about I/O consolidation, LAN and SAN convergence, the whole evolution of allowing or enabling applications to run across a unified fabric. That built on the fact that UCS used the unified fabric as a core element of it, but we did much more than that. The unified fabric was one element of innovation. The other elements of innovation were bringing together compute, networking, and storage access into a converged platform, which really became the basis of what we call converged infrastructure with vBlock and FlexPod. At that time, we were trying to solve the converged infrastructure side of the marketplace. As you see the same elements that we brought together on the UCS platform, including the constructs of a policy-driven service profile, we are taking those exact same pieces of innovation and now bringing it closer to the network, which is policy-driven, and that has embedded capabilities through that policy-driven model to accommodate applications that can now get the types of services out of the network and the infrastructure in a far more agile manner and a far more programmatic manner and in a far more secure manner at scale. So that is basically the crux of ACI, and that becomes the foundation for Cisco to deliver on cloud, whether it is the ability for our customers to build on-premise private clouds that are secure with embedded security, whether it is have the ability to use that same policy-driven model as they burst to the hybrid cloud, and even go beyond it to the public cloud, so that as we integrate through Azure Pack into Microsoft Azure, you could foresee using a common portal with that same policy-driven model to define the workloads and applications that you want to have corresponding to your on-premise secure private cloud infrastructure, and go back to that same portal and use the exact same policy model to define the applications and their policies that you want to burst to your Azure cloud. Okay? So this becomes a foundational building block for Cisco to enable the cloud models going forward. For the duration of the policy that you have defined, the policy and the security elements move with your workloads and with your applications. So what is the end state for ACI? The end state and where we want to take the market with ACI is day one, have the ability for our customers to automate their physical networks, their multi-vendor hypervisor virtual networks, or even containers-driven networks. The ability to automate through this policy-driven model their existing layer 4 through 7 services, which includes firewalls, intrusion prevention systems, and intrusion detection systems, physical and or virtual. And the ability to span multiple data centers, initially through the stretch fabric, spanning up to 100 kilometers, and in the near future, the ability to span wide area network and geographic boundaries. So now you can foresee having a disaster recovery, a high availability, alternative data center location with full policy federation that you would have the ability to apply. In the short term, as I said, spanning up to 100 kilometers, and in the midterm, the ability to take it beyond into the wide area. Okay? This policy model is not just constrained to your network and your network services, but is extensible to accommodate and move into the compute as well as into the storage arena. So day one, we allow you to connect any endpoint, into this network. It could be any compute, it would be any storage element. It could be any hypervisor, because we normalize the endpoint. It could be any bare metal environment. For us, because we are a networking, the level of automation and policy-driven models is driven out of the network, we would accommodate any endpoint, physical, virtual, or containers. It is ultimately about your applications, and to allow your applications to be placed where you need them, when you need them, whether it is across different data centers, with the same policy-driven model that can run on-prem and into the hybrid cloud, with full visibility to your physical and your virtual. This is a very unique element that only the network and SDN principles in the network can support. The reason is because when you are building an underlying infrastructure, you will still need to support and maintain that underlying infrastructure. So when you support an SDN model, you need an SDN architecture to give you the visibility of real-time information, whether you wanted it at an infrastructure level, or whether you want that visibility at an application-centric level, or whether you want it at a tenancy level. And what we have done is that we have enabled you to manage your physical and your virtual networking assets with real-time visibility across this model with ACI. So if there are any issues, your mean time to repair is very quick, because you're able to quickly identify, is the network the problem? If it is the problem, where is the problem? And quickly isolate it, whether it's down to a port level, a link level, or a box level. Okay? The three key elements of ACI really are focused around the tenets of the following value. The first one is around automation. 95% of all of our ACI customers that have taken this technology into production are automating their networks. That's table stakes for them. The ability to free up 40% of the OpEx budget is the net value that they experience through the automation of the network. So the amount of time that a networking team is spending in deploying networks, delivering services over that network, shrunk by 40%.
So with those teams that are reducing their OpEx, or their time spent on that sort of stuff, what are you seeing them do? Are they, like, with that extra time, are they going, well, okay, I can, sorry, you're not required anymore? Or are they using those people in a different way? What are they doing with that?
They are reusing those people. It's providing the networking teams an opportunity to develop skills around writing to programmatic APIs. Because one of the things that we have delivered, in addition to a zero-touch provisioning networking model, is we have driven to our customers an object-driven networking model, which is highly programmatic. And if you have the ability to write to the APIs, there are a lot of automation and capabilities that you can derive out of knowing that API-driven model, where you can add value not just within your day job of a networking person, but you can add value to your security organization.
So you're seeing people, you use it and use those skills in better ways, do more, like all the stuff that we want to do, but we get tied up.
Those resources now,
and
stuff. Now you're able to repurpose those folks into delivering more cloud-enabled IT practices, more service-oriented delivery vehicles, because you have now freed up their time. You're helping them develop themselves by going and learning how to write to a Python or how to write to an XML-driven API.
And you're seeing that sort of stuff as well, the network engineers moving to that model, as opposed to, I guess, you can sort of come at it from the network side, or you can come at it from the developer side. So you're seeing teams are sort of taking those network people and moving them towards that programmatic.
It is still early days. I would not say that it's happened right away. I think this is the evolution. This is how we see the trend going. Because the thinking is that I don't have to do away with my subject matter expertise. But if I can free up the time, because now I'm automating a lot of those functions, then I can repurpose those people give them more talent, allow them to learn new skills, and now they have the ability really to sit with the application teams and or the cloud teams and to deliver the right services that the infrastructure team can now deliver to that application development organization, right? Because if I can do more with less, I can then repurpose my team to now meet the needs in a more agile manner of the app teams without leaving behind the applications that I had that were over 10 years old.
Yeah, because they're still everywhere.
Exactly. So the key point is that as our customers are evolving towards this cloud development model, whether it is using containers, moving towards a DevOps model, we want to enable that success with ACI, but we don't want to go back to our customers and say, but by the way, that ACI network cannot support your 15-year-old mission critical workload, that bare metal workload we don't leave that behind. Because an ACI network ultimately at its root, at its base, looks like an big IP routed network, right? It looks like one big gigantic IP router. You could connect any device with an Ethernet address into it. You would be able to connect any device with an IP address into it. And that's the advantage of bringing together the physical and the virtual. We don't leave behind our customers' heterogeneity and the mission critical environments. And the ability to have real-time health metrics of that infrastructure, whether it's your physical networking infrastructure or whether it's your virtual networking infrastructure through a single pane of glass, gives you the ability then to have real-time telemetry and visibility. Now, for us, security is not something that sits outside. Security with stateless firewall functions is an embedded part of the network. So when I turn on an ACI network, 70% of our customers' use cases that are oriented towards stateless firewall functionality, a lot of those use cases are embedded at wire rate in this network. Okay? And when it comes to having an open strategy, we definitely not only have an XML northbound API, but we also have delivered across the southbound API the set of calls to the IETF with 7 other companies. And where this policy model never existed, we have contributed it into the open source community. So this group policy model, you can go to Open Daylight today and you'll be able to download the entire group policy model. We also have contributed it into OpenStack. This policy model also has been embraced into the Linux kernel. There's today an OVS implementation of this policy model available in open source. The second key element of security, one being the stateless firewall, is the second capability from a security point of view is multi-tenancy. So when I define these policies, I have the granularity to define it across tenants. So if I'm a cloud provider and I have Coke and Pepsi, or if I'm a Symantec, an enterprise customer that is going through a divestiture, I can have one network with 2 completely separate tenants and meet very different needs if that one business is in the security business and has a huge compliance requirement, and the other tenant, which is my storage business, and now I'm giving you the example of Symantec, because they had an ACI underlying infrastructure, they were prepared to go through this divestiture, with ACI being the common foundation for them, with built-in multi-tenancy and a policy-driven model that allowed them the ability to go through with immense flexibility and yet deliver the compliance and security elements to businesses that needed to be treated very differently. Any questions on this chart? At the base of ACI, there is a clause fabric, a leaf spine architecture that is centrally managed through a centralized management controller. If for any reason that controller cluster were to fail, your network will keep running. Your policies continue to be retained. Even as your workloads move around that network, the policies will traverse with those workloads. It's only when you have to deploy new policies is for which that you would require the controller. This is a very unique implementation from software-defined only controllers, where the controller is either in the data or the control path.
So the
for
control
alternative
is only
solutions.
it's only when you're pushing out a change as such, but ongoing dynamic stuff or whatever.
It's never in the
workloads
data path,
moving,
it's never in the control path.
links failing, whatever, stuff like that.
The network is on it's an autopilot. You've got the network doing its portion of the business, and the portion of the business that is the APIC controller's business is purely management and policy engine. But the policy repository is sitting distributed across this entire network. And any movement of workloads will not require the interception of this APIC controller. The policies will move with the workload or the endpoints that you have already defined without any intervention. Therefore, with just a cluster of 3 APIC controllers, I can support up to 1 million endpoints here. V4 or V6.
Preempted the V6 one, eh?
Yep. Now, we have complete investment protection for the networking infrastructure that our customers have already invested in. When I was at Cisco Live in Europe, I had the opportunity to invite a few customers up on stage with me in my keynote, one being QBranch. They're a cloud provider in Europe. In Sweden, they're the largest hosted cloud provider. And QBranch has a huge investment in the Catalyst 6K. So as they were taking ACI Stretch Fabric into production, they didn't go out there and rip out their Cat 6K infrastructure. They retained their existing customers onto that Cat 6K network. And through VLAN, they were able to map those sets of clients that were on the Cat 6K network into the policy-driven model of the ACI network. So with the ability to have full investment protection, ACI will allow our customers to retain the investments they've already bought, and in parallel, move towards a policy-driven model with ACI. We don't leave behind the existing IP networks that our customers have deployed. Okay? This architecture normalizes the endpoint. So whether you are coming into this network with a VMware hypervisor that you are managing using vCenter, there's full integration of our APIC controller with vCenter today. Or if you happen to have a Red Hat hypervisor, KVM, and you're connecting KVM-based hosts into this network, we have the ability to have full integration with OpenStack and the Red Hat distribution through the APIC controller and our ability to support that. If you have a Microsoft Hyper-V set of users connecting into this network, we have the ability to support that. And in a future release, APIC is fully going to be integrated with the Microsoft System Center VMM. And the exact same thing holds true for Zen, where we have today integration with CloudStack through the northbound APIs and the ability to support Zen. SunGuard is one customer who's in production with ACI with a Zen CloudStack implementation. We normalize the endpoints. So you may have the ability to route and switch classic networks, overlay networks coming in from hypervisor environments of today. Okay? From a compute perspective, full integration with all the compute environments our customers have. And in the future, we will be driving further synergies into the UCS. Storage, we are tightly integrating with the APIs of NetApp and EMC. And today, we completely support the storage as an endpoint. Layer 4 through 7 services, this is a unique advantage that we have over the rest of the marketplace in the ability for us to have and protect the rules that our customers already have, whether it's on the F5 devices, their checkpoint devices, and our ability to integrate those rules and those devices through the integration of our policy model and plugins that these companies ship, the ability to have them supported through a centralized policy model. What's the net advantage of that for our customers? They don't have to disrupt their existing firewalls and intrusion prevention systems environments. They have the ability to come to one location, one policy controller for policy and compliance information, as opposed to going to 10 different locations. And as they make changes in the policies, they have to come to one place to update their policies, allowing them the ability that tasks that used to take them 4 to 8 weeks to complete, between tickets that would go from the networking team to the application delivery controller teams to the security teams, can now be done in minutes. You're now automating not only your networks, but your security operations teams, your application delivery controller teams. Less human-prone error, right? Because you don't have humans repeating the same set of tasks manually. And a far more agile IT experience. Our own IT organization has experienced 58% quicker response times as an infrastructure team to our app teams as a result of this functionality.
Just a couple of questions coming in via Twitter. This is what we can do with Tech Field Days. You were talking there about some of the integrations, say, with Checkpoint. And so Keith's just sort of interested in what are people doing there? How's that working in terms of real workflows and stuff? Is this like a service chaining type thing, or how is that actually working in practice? What are people doing?
So we are basically doing two functions. One function is chaining of services in the network. So you would have the opportunity now to have multiple devices. Let's say you might happen to have F5 application delivery controllers. And you might happen to have rules that you've already preset with Checkpoint. You would have the ability, once you have the plugins available shipping out of F5, but you can access it on our website or the F5 website, and plugins shipping from Checkpoint.
Are the Checkpoint starting to do plugins as well?
Exactly, for ACI.
Yeah, because like I've done a lot of work with Checkpoint in the past, and they've always been kind of painful to integrate with other things. I mean, they're changing that on their side as well, but yeah.
Right, but they're going to be releasing, if they already have not released, the ACI plugin.
Oh, cool.
It was slated to come earlier this quarter, but if it has, and we can check that and get back to you as to the status of the plugin. But
I hadn't seen any announcements around that, so
yeah, the announcement went out in December.
Yeah, so I haven't heard of it being released or anything. So it's
we can come back to you and give you the exact date of the release of the plugin.
Cool. Thanks.
So there are two advantages with this model. The advantage number one is, if I happen to have F5's I rules, which are very sticky, and many enterprise customers, financial services customers, have got an immense sophisticated way of integrating into these I rules, you don't go in there and you don't disrupt it. It's like the holy grail for the sysadmins, right? We protect those, we retain those, but we have the ability to integrate using this plugin, their big IP and their big IQ appliances through this plugin. So I retain those rules, but from now on, as I add more policies, I not only have the ability to retain and protect those policies that the users had already deployed, but I now come to one place to enter new policies, i.e. the APIC controller. And now I have the ability to not have to go to multiple different places to apply those rules, those policies.
I think this is tying into something else that Keith's asking about around similar workflows being created with different hypervisors. Because if you're supporting VMware, say you get some VMware, some KVM, whatever going on, there's always different caveats around this hypervisor, I can do these functions, this I can do that. They've all got their own ways of doing things and whatever. But I guess I think what he's asking is around, if I can deal with this more at the APIC layer. I can kind of abstract those lower levels. I want to do a similar workflow and apply that across the different ones.
That's exactly right. You would come to one place, which is the APIC controller, and whether that policy, we call it a policy or a profile, whether that policy or profile that you're creating is for a physical service, as part of you in that profile, you would define what is the collection of these endpoint groups. You can define it to correspond to a VLAN at the least common denominator level, right? Where you say an endpoint group is defined as VLAN 1. Endpoint group 2 is defined as VLAN 2, right? Let's take the basic model of doing this definition. But I want to have the ability to stitch the services of firewall coming from vendor A, and it could be checkpoint, and application delivery controller coming from vendor B. And I also want to have the ability to have a virtual network service that can be chained into this policy model. And I want the network to not only support the service chaining of my physical workloads, but also my virtual workloads. Because the APIC serves for you as one place for you to come to in order to support network chaining for physical and network services, right? And one place for you to come to for automating and driving that policy model, driven model through these plugins. Okay, so it's really got two advantages for a customer. When now I'm not manually, physically stitching those services in a network across my different organizational silos. I'm automating that function. It's an embedded part of the networking functionality. The second thing is, I come to one place for the policy-driven model for my network and network services, whether they are physical or virtual. I can do it with a single pane of glass.
You were talking about integration with external vendors, like firewall vendors.
Yes.
Does that mean that you are effectively doing firewall configuration in APIC? Or do you still have to configure additional parameters, let's say, in the firewalls themselves?
So for our customers, it was extremely important. If you start with a greenfield deployment, we would have the ability now to, through the plugins that we're offering for vendors like F5, you would have the opportunity to drive, because their plugin is very sophisticated, where you have the ability to integrate their iRules, their big IQ appliance, and their big IP appliances. There's a lot of functions where you can come to the APIC controller, and through the plugin, you will be able to launch some of those services, but you won't necessarily have to keep going back and forth between their appliance and our appliance. You would come to one place, i.e. the APIC controller, and through the sophisticated plugin, we are striving to go with deeper integration to deliver our customers the experience of allowing them to come to one place as much as possible. However, there is another set of customers that want, for compliance reasons, the ability to have their security organization come in and do that piece of the work. So you have to support both models. You cannot say, there's only one way I do it. And the other key attribute, which is a differentiation for Cisco vis-a-vis other SDN models, is we allow our customers to protect their existing rules. We cannot go to a customer and say, throw away all your appliance rules. Let's go redefine it. It's a different way of doing things. You have to support what they already are running in production. You have to allow them to protect those assets and those programs and those rules that they've already implemented.
Yeah, glad you mentioned that. Yes. Now, if I believe in full integration with APIC, and I already have a brownfield environment, can I somehow import the existing load balancer and firewall configuration into APIC?
Yes, not into APIC. You are now mapping through the plugin of that device. You are retaining those exact same rules that you had defined. You don't change those. I would say 90%, if not 95% of our deployments are doing exactly what I just told you. They are retaining the state of what they are using, But they are moving towards this notion of network stitching, which is dynamically happening in the ACI network and coming from one location, which is through the plugin, the APIC controller, but retaining what they already have deployed in a brownfield. 90% of our deployments are brownfield, and they are retaining those rules. Okay? And last but not least, our ability to integrate across our WAN routers. So in this calendar year, you should expect both the ASR 9K as well as the Nexus 7K, both being a multi-data center interconnect platforms, to have the policies that they are managing through the APIC controller to span your data center interconnect.
So that's primarily, talking WAN, that's primarily connecting your DCs. It's not so much about broader WAN.
It's connecting DCs.
Yeah.
Connecting DCs.
Because I'm interested in the broader WAN as well, but
okay.
Yeah.
So we should have that maybe Mike Herbert can talk a little bit about that.
Actually, Carly's going to cover a little bit of that.
Very good. Awesome. And then our ability through the northbound APIs to integrate into customers' existing system management tools, hypervisor management tools I already touched upon, orchestration frameworks, including OpenStack, as well as Microsoft Azure, and systems management tools coming from BMC CA Tivoli.